Okay, we're going to continue with Jdbc here in a moment, but just highlighting what you should be doing over the next couple of days. You should be drafting your design document. This is now draft 3. So all that stuff that should have been there from the beginning, you know, the introduction, the overview and stuff like that, that should be very mature at this point. But what we're going to be focusing on is your database design, right? Your database design, including and most importantly, your ER diagram. You want to diagram what you're going to plan for your database so that we can give a good feedback on the design, right? You should have a clear description of your tables, of your columns, and the relationships between the tables, right? So that's what you should be doing for the next over the next couple of days, right? Anyway, back to Jdbc. So what we covered last time was just a getting started, and we also gave a quick overview that I want to review now. Basically, our goal is to programmatically connect to a database. Over here in MySQL Workbench, yeah, you can go ahead and work in MySQL Workbench. If you end up being a DBA, a database administrator, or data scientist, or something like that, you might live most of your professional life in an IDE, something like this, right? Hopefully, you'll have a little bit better one that that they pay for instead of MySQL Workbench, which is free. But we want to programmatically connect to a database with our Java code because we don't want to have to manually insert data into the database. We don't want to have to manually pull it out and produce a report, right? We want to write a program that does that for us and displays it to a user or something. Much like reading CSV files, what we're going to start doing is start reading from not CSV files, but from the actual database. We're going to be using Java Database Connectivity API. Remember that an API is an application programmer interface. The key word there being interface. Remember the solid principles that we are using basically dependency inversion, right? We're not programming towards a particular database, a MySQL database, or a Postgres database. We are programming towards that particular interface. The vendor, say Oracle in this case, who owns MySQL, provides a driver library that we bring into our project. In this case, it was this MySQL connector J file, version 8.3.0, right? That then provides the actual, functionality of that API. We're going to keep it simple. This Jdbc library is quite large. We're going to keep it simple and focus only on 3 things that you need to connect to and interact with your database. One is that you need an actual connection, and we went over that last time. We'll review that here in a second. Then once you have that connection, you need to create a statement, an SQL statement. If you're inserting something, it'll be insert, right? If you are selecting things out, it'll be select. You can do updates and deletes, right? Anything that you can do over here in MySQL Workbench, you can create a statement to do that for you over here in Java. If it is a select statement, you expect results back. Of course, if it was insert, update, or destroy, you're putting stuff into the database or changing stuff in the database. You're not expecting a result set back. But if it's a select statement, then you are expecting a result set back. Even if it's empty, an empty set is still a set, just like in 235, right? So result set, we will need to process that somehow. There are object relational models. You'll see when we start writing Jdbc code that is a lot of boilerplate. A lot of stuff where I'm going to get the first name and put it into this first name. I'm going to get this last name and put it in the last name, right? There's a lot of boilerplate stuff just to load stuff up from a database. And there are libraries out there called ORMs, Object Relational Mappings. For example, JPA in Java, Java Persistence API, that make this boilerplate code far less, right? There are challenges to it still, and it doesn't get rid of the need for Jdbc. In fact, JPA is written on top of Jdbc, but it can take a lot of the grunt work out of it, a lot of the boilerplate work out of it. If you are interested in this, I've got another video that introduces it, but get your Jdbc stuff working first. Only look at JPA, learning JPA as kind of an extra thing to do. But I do want to mention it so that you are aware of it, right? All right, so what we did last time is we connected to the database, right? We had our server URL here. Here's my username. Your username will, of course, be yours or your partner's. You need to decide on one or the other. And then, of course, your database password, okay? I'm not showing that to you because I don't want anybody screwing it up, right? But once you've got a connection, then you've made a connection, make sure that you are closing your connection. A failure to close a connection will lead to problems. If you open up a connection, don't close it. Open up another connection, don't close it. Open up another connection, don't close it. Once you get to 30, that's done. You're done. There's no more connecting. Let me show you. For int I equals 0, I is less than, say, 30, I plus plus. This will probably work, right? I will be able to open up 30 connections without ever closing them. And I can get rid of all of this stuff here. There we go. Just for now, for a second, right? I could probably open up 30 connections and be just fine, except that I'm already connected over here. Show process list. Remember, we use this to show all the connections. There's 2 connections. One is keeping this open. The other is actually running that show process list. So once I got to 30, right, 29 was probably okay, right? Nope, didn't even get up there. Oh, yeah, it already has a max number of user connections. Maybe 28 would be all right. Let's see if that works. Yeah, 28 was fine. But once you get up to 29 and then you hit 30 and you try to ask for more, it's going to run out. So make sure that you are always closing your connections, just like a file or a scanner or something like that. Usually when I write code and I open up a resource, I immediately write the code to close that resource. And then I go back and do something with that resource so that I never ever forget this step. Because it's going to be 100 times more important now to not forget this step. If you didn't do it with a file or a scanner, you just risked corrupting that local file. But now you risk running out of connections entirely. Right? And now you're going to be waiting for 5 minutes for everything to get reset. Okay? All right. Wow. Opening up a connection, or having the URL, username, password, opening up a connection, closing a connection, that sounds like I'm going to be doing that many, many, many times. For a query to insert a person, for a query to retrieve their emails, for a query to insert an email, for a query to, a query to, a query to, a query to. Wouldn't it be good to not have to cut and paste all this stuff over and over again? Right? Where should you put this kind of stuff? In some other class, in some other method. That's called a factory method. A factory method is going to produce connections for you and give those back, so that you don't have 50 copies of your password somewhere else, right? That's going to be worth bonus in your future phase 4 or whatever it is, right? But for now, I'll go ahead and leave this as is, because what we want to do is we want to actually pull data out. So let's go ahead and pull all data from the person table and print it out, ... right? All right, what would that look like if I did that? I'm already using my database over here, so select everything from person. There we go. There are 4 people, me, Babe Ruth, LeBron James, and Blake Snell, okay? So I want to pull out all of their information, create objects, right? I've got this person object already. I want to create a person object out of that data that I'm pulling from the database. And then I want to print that out, all right? So how are we going to go about doing that? Again, there is this process. The first step is we've already got there, is you're going to create a connection to your database. You need those things. Then you prepare your query, right? You prepare the query and you execute the query. Right? This is going to be an important process. It's not just a matter of writing a query like this over here. It's going to be a matter of writing that query over here, but then also sanitizing it, and we'll talk about that here in a second. Then, of course, if it's a select statement, you want to process the results. Process the results, because you're expecting a result set back. Then you need to clean up your resources. Any connections need to be closed. Any result sets need to be closed. Any prepared statements need to be closed. So let's go ahead and follow that process over here. 1, I've already created the connection. 2, create and prepare your query. So what's my query going to look like? It's going to be a string. I'll just call it query because that's what I'm doing, right? And I'm going to select everything from the person table. This is why I like to have 2 IDEs open at multiple times. In fact, this is why programmers always have multiple screens, at least 2 screens, if not 3 or even 4, depending on how many you can handle. Why? Because you have an IDE over here. You have your other IDE over here. You have your results over here. You have your tests over here, right? If you're always going back and forth or something between different desktops, it can get quite confusing. So I like to have it open over here so that I can write my query, run it and see, okay, yeah, it works. That's great. Now what I can do is I can cut and paste that and bring it over here into my Java code. Right? There's no way that I'm going to be able to run this without running the entire program. But over here, I can troubleshoot. And oh, there's a syntax error. I wonder what's wrong with that. Come back over here, fix it, and then bring it on over here to your database code. Now, strictly speaking, you don't need that, that semicolon there. Right? But if you're going to bring things over, just be consistent about it. Another thing that you don't want to do is use this wildcard here. Ultimately, you know, I could, ultimately I'm only storing like the ID, the first name, the last name, and the date of birth. But what if I were storing an image of that person in this table, right? I would be pulling over all that data, right? Like say 3 megabytes per person or something, even if I don't end up using it. We'll talk about that at best practices later on. For now, I'm just going to leave it, okay? There's my query. I now need to prepare that query. Lots of things can go wrong with the query, right? For example, if I were to insert a person with the name O'Brien, right, there's going to be an apostrophe in there. That apostrophe, it needs to be escaped. I can do that manually, but when I'm writing code to bring in something, say, from a form or something like that, or from a user input or something, I don't want to have to worry about any of that stuff. So I'm going to end up preparing my query and letting the JDBC do it for me. So let's go, sorry, over here. Prepared statement. Statement is just a statement. It could be an insert statement. It could be a select statement. It's just this abstract notion of a statement. It's prepared in that it's going to handle all those details for you, right? So prepared statement, PS, is equal to, not a new prepared statement, but we need to use the connection to prepare our statement. Prepare, not call, statement. There we go. And my query. There we go. I do need to bring this in. This is going to be in the java.sql library. Right? That's not compiling because I need to surround that with a try catch. Okay. Every single time I do something with this library, I'm going to be forced to generate that code, copy paste this throws statement and put it down here. Every single time I do a line of code that's going to do something like this. You can go ahead and take the track that take the approach that I'm using right now, where I surround each and every single line with a try catch. But man, that gets unwieldy really quick. Right? So what I'm going to do is I'm going to go ahead and move all of this stuff into one big try catch. Right? And I'm going to move this connection down, closing the connection up here. And I'm going to move this prepared statement right here, there, and get rid of all this. And there. Right? In other words, only one try catch for something major like this. Right? If something goes wrong at line 21, right, then it'll catch it. If it goes wrong at line 19, it'll catch it. Right? I'm not really concerned about what happens where. I want everything to be running nicely anyway. Right? If there's an error at 18, if there's an error at 25, it doesn't matter. There's an error, period. So why be more fine-grained about that? All right, so I've got my connection. In fact, I can label that 1, make your connection. And then down here, that was step 4, right? Close your resources, ... All right, so, and here I've got my select statement and my prepared statement. Yeah, go ahead.
Error, like in the error output, it'll tell you what line the error is on.
Exactly, yeah. For example, if I don't spell my name correctly, there we go. What line did it, first of all, is that my code right there, SQL error.java line 130? No. When you're doing debugging and when you're looking at the error codes like this, you need to read them, right, carefully. Where does my code actually start? This is an entire stack trace. Where does my code actually start? Right here, right? Main on line 19. Now, instead of going fishing for that line, you'll note that there's a little finger right here, right? That means that I can click on that and it'll take me right there. Right? So make sure that you're using your IDE tools to their fullest. Right there, that's the line number that's wrong. Why is it wrong? Well, you read it closely here, and I misspelled my name there, or I misspelled my login. There we go. Now it's back to normal. Okay. All right, I want to select everything from person. Actually, let's go ahead and try this now and see if it works. Okay, it works. I was hoping that it would not work because we missed one crucial thing up here. What database am I using? Certainly I've got the server here. Certainly I've got my username and I've got my password stored somewhere else. But anytime that you're working over in MySQL Workbench, what's the first thing that you have to do? Use that database. How do you do that over here? You could if you wanted to execute that statement, but that's not the way that you want to do it. The way that you want to do that is by putting it in the URL. There we go. This right here is a substitute for use that database. In fact, if you want to, you can go ahead and concatenate the username right there, right? Because it's going to be the exact same. Right? There. Now you don't have to write that twice, right? For whatever reason. Right? It didn't save you a lot, but whatever. All right. Before I continue, follow that pattern. You open something up, you need to close it before you continue. So close your resources. A prepared statement is a resource that needs to be closed. Close. Now, careful. Is that the correct order? Well, what order did I open them up in? The connection gets opened, and the connection gives you this prepared statement. So if you created them with one connection, two prepared statement, what order should you close them in? In the reverse order. So close your resources, close your resources. Good. Right. Now I need to execute that query. To execute that query, I'm just going to say ps.execute query. There we go. And it returns me a result set, rs. Note the names that I'm giving these things, query, ps, rs. Right, those are kind of, I agree, those are kind of bad names, but can you think of a better name? Right? The only other better name here would be the prepared statement that queries all people. Right? People. There we go. Right. Is that a better name? Probably not. Right? So if you can think of a better name, please let me know. Otherwise, that's good enough. We need to bring this in now. Import this. That's another resource that needs to be closed. So if I open it up, connection, prepared statement, result set, they need to be closed in the reverse order. rs.close, prepared statement close, connection close. Okay. Again, failure to do this, you can cross your fingers and hope that it gets cleaned up automatically. Right? The second that your fingers fail, though, then it's not going to clean it up properly. Right? Always remember to close your resources. Now we can go on to 2B, I guess. That was 2A, right? Process the results. Okay? Let me come over here and look at the results that I'm expecting back. I'm expecting 4 people. Me, Babe Ruth, LeBron James, and Blake Snell. Right? Now, how would I process this? It's going to give me back, this is a very old school way of doing it, but it's going to give me back a result set. Initially, what I've got is a pointer. I want to point to the first one, the second one, the third one, the fourth one, etc. Initially, what's going to happen is the pointer points before the first one. I need to advance to the next one. I need to advance to the first person here. To do that, I will use rs.next. That gives me the next person. Now I can process that person. rs.get, say, their last name. There we go. And that returns a last name. String last name is equal to. There. Except that I'm going to be doing this multiple times. So should I take go to the next one, right, and process their last name, rs.next, right, and process their last name, et cetera, right? Well, what if I did that 4 times? Actually, let's actually print them out. System.out.println last name. There we go. And let's do that again. In fact, let's do that 4 times. Right? Let's run it and see what happens. There. Me, Babe Ruth, LeBron James, and Blake Snell. Right? Should I be doing that? Should I be copy, pasty? No. So what should I do instead? Some sort of a loop control structure. Fortunately, this next operation of going to the next, and the next, it also returns a Boolean. If you read that small little piece there, it's return type, right? That it will be true. You're pointing at the first one. True, you're pointing at the second one. True, you're pointing at the third one. True, you're pointing at the fourth one, right? Now, when you go next after that, it's going to return false. So it's very naturally put into a while loop here. Why a while loop, by the way? Do I know how many results I'm going to get up front? Not unless I make yet another query, and I'd have to process that query anyway, so might as well just put it into a while loop. While it has more results, that's very similar to a scanner, right? While it has another line, process the next line. Next line, next line, next line, next line. Except that it's all in one line here. This next advances to the next record, and returns true if valid, right? It points to a valid reference or record, right? False if no more records. That's great because that will jump us right out of this while loop, and we go and we close everything, right? So let's run that and see if it works exactly as before, right? Just 4 people, okay? Now I want to do something more with that, right? I want to actually get their last name. I want to get their first name, right? How was I doing that? Well, the result set is pointing to the current record. If you get this column here as a string, it will give that to you. If you get this column as a string, it'll give that to you. This is the boilerplate that I was talking about. Man, it would be nice if I could use a library to do all this boilerplate for me, and you can, right? But we're not going to. Right? Instead, I'll give you resources if you want to look at it, right? And a string date of birth, birth, except what was date of birth? Yeah, it is a string. Right? Let's go back over here. Date of birth, date of birth. Right? Except that in Java, is a date of birth a string? Bad modeling, yeah, it would be a string, but we have something better, right? What should we be using instead? Hopefully everybody's using it in your projects. How do you calculate the number of days between a lease? A start date and an end date? It's what? Local date, right? That's what my date of birth should be, right? Is equal to local date dot parse, right? Date of birth. Oops, date of birth. So I can't have 2 variables with 2 different types called the same thing, date of birth and date of birth. So I'll call this one str or something, right? And I'll go ahead and take care of that, right? Instead of printing it out, let's actually make a person now. Person P is equal to new person. Now, how can I create a new person with that constructor? It takes the last name, the first name, and the date of birth. So the last name, first name, and date of birth. There we go. Wonderful. Now we can print it out. System.out.println p. And let's run this. And we get all their information. We're not printing out the date of birth or anything like that, but we are successfully getting it now. Is there something else in my database that I probably want? I see a first name, I see a last name, I see a date of birth. What else do you see? What was this thing called? Primary key, right? Might I want to pull that out as well? So let's try it. Person ID is equal to rs dot get string person ID. Right? Well, wait a second. First of all, is it a string? Do those look like strings to you? No, what are they? An integer, right? Int. So if you have a different type, you can get int instead. If you have a double, you can get a double, right? Generally, I will restrict our attention to strings, varchars, integers, and doubles. So I'm just going to go ahead and go with those. But of course, you do have like dozens of more, dozens and dozens and dozens of getters here, right? If you want to worry about that stuff. I'm just going to go ahead and get int, right? What do I do with that? Right? Why would I want that, by the way? Eventually, I'm going to want a person's emails, right? Let's take a look at how I designed the person class over here. They also have emails, right? That's in another table. How am I going to retrieve the emails of LeBron James there? Select everything from email. Oops, email. So there's LeBron's email at Lakers.com and at Cavs.com. Right? I need to get his 2 emails and add them to that person record. What's the only way that I'm going to be able to do that? With that foreign key. So yeah, I definitely need and want that person ID right there. That means that probably I want to redesign my class a little bit here. Right? You can always go back and change things. Private, int, person ID. Right? That person ID will be a connection to the database. Right? So this will be our database primary key value, dot, dot, dot. Now this is terrible. I'm not going to leave that, but I'm putting that in there for demonstration purposes. Okay? All right. Well, how do I get that in there? Do I just go ahead and add it to my constructor here? Int person ID. Right? You'll note, however, that that breaks everything everywhere. Right? If I was using this person class in 10 different places in my code, and I just changed this one and only constructor here. Actually, there's another constructor down here. But if I change that constructor, I've changed it everywhere. Better idea? I don't want to have to break any other code. How many constructors are you limited to? None. Oh, yeah. You are not restricted to any, right? You're not restricted to any number of constructors. So let's add another one. I don't want to break that code, so I will create yet another constructor here. Int person ID, and then this dot person ID is equal to person ID. Oops, ID. There we go. There. All right. I've got a lot of repeated code here and a lot of repeated code here. What should I do now? Just like I did over here, I should call this constructor on the last name, I don't know, question mark for the person ID. Last name, comma, first name, comma, date of birth, and then it takes care of the instantiation of the email list for me. Oof. What value should I pass as a default value for person ID? -1, except that you can insert records with negative values because it's an integer. Insert into person, person ID, last name, first name. Actually, that's all I need. Values, -10. Foo. There we go. There, it worked perfectly. There's Mr. Foo with -10. 0? Nope. You can insert Mr. Bar with 0. Perfectly fine. There's Mr. Bar now. Right? All right. Well, I'm stumped. What's another value that would mean I don't know, that this is definitely not an integer, that this is definitely not a valid value from the database? No. That's a great idea. Right? It's not an object, but we didn't have to make this a tiny I integer. Integer. Now, when this is null, then it has no connection to the database whatsoever. You can go ahead and create a person with a last name, first name, date of birth, and screw around with it all you want, right? And they don't have a person ID, right? Because there's no connection to the database. This version, will have a connection to the database, in which case this will not be null. It'll be an actual value. If it's Mr. Bar, it'll be 0. If it's Mr. Foo, then it'll be -10. If it's LeBron James, then it'll be 3. All right? What are you complaining about now? Last name, first name, date of birth. Oh, thank you. So I changed it up there, but I didn't change it right here. There we go. Well, I did. Integer. There we go. There we go. Now we're all fine. Right? In fact, this might have been a pattern that you followed with your object-oriented programming with the hierarchy. If you have, you could create an instance of a product or a lease or something like that whose value you didn't know yet because it wasn't actually in a sale, right? Probably not the best use case for this, but you could think in terms in those terms, right? I don't have enough information to say what this is, therefore I'm going to go ahead and make it null. Okay. All right. That looks good. Now I can pull out that person ID, add it to that, and I've got now a connection to this database. Instead of printing it out, let's go ahead and not just load up all the people, right? Pull all data, just one person. We're going to load up all the people from the database and print them all out. So let me go ahead and create a list of persons, right? Everyone is equal to new array list. There we go. Bring that in. Come on. Bring that in. There we go. Everyone. And instead of printing them out, I'm going to add them to everyone. Everyone.add p. There. At the end, I can print them all out. System.out.println everyone. Or do whatever I'm going to do with them. Right? Oops. What was wrong? Oh, yeah. Darn it. So, Mr. Fu and Mr. Bar do not have correct dates of birth here. All right? So let's go ahead and fix that. Mr. Mr. Fu was born yesterday, 2024, 03/19. Right, there we go. And let's go ahead and change Mr. Bar to be 19/01/01/01. There we go. Careful, did that change my database? Nope. Instead, when I'm about to close this, it'll ask me, wait, do you actually want to save those changes to your database? Yeah, I do. Right? In fact, it'll generate code for me to do this. Remember when we said insert as much test data as you can? You can do it manually, and then it will show you the code to do it. Right? Apply that. Close that. Let's go ahead and select all the people, and there. Now everybody has a valid birth date. Let's run this again to see that everybody does have a valid birth date. There's Fu, comma, null, that's their first name. There's the rest of us, right? And then there's Mr. Bar with a null first name. Okay? All right, well, okay. That's kind of cool, except that do I have everybody's emails? In fact, let's come over here and modify this so that the toString method, where is it? Where's the toString? There we go. I'm going to go ahead and concatenate all their emails, plus space, emails, whatever, plus this dot emails. There. And let's run this again, and we'll see that they don't have any emails, they don't have any emails, they don't have any emails, but I know that there are plenty of emails in this database right now. In fact, there are 3. Right? So let's pull out that information. Right? So option 1, we also want their emails. Option 1, use a join statement or join query. Right? So remember that we were just selecting everything out of person. What would that look like over here in my SQL workbench? I don't want just the person stuff. I want everything from person, P, left join, because we want to make sure that even if they don't have any emails, that they're preserved. Let me show you what happens when that doesn't happen. Remember, if you just join to email E on p.personid equals e.personid, we're going to get me and LeBron there, but we're not going to get Mr. Fu, Mr. Bar, or Babe Ruth there because they don't have any emails. All right? So I want a left join to preserve all those things. Right? I want everybody, but I don't. If they don't have any emails, then we're just going to have null here. Babe Ruth and Blake Snell don't have any emails. That's option 1. All right? Except that that's not an ideal option, because remember, I am using network resources. What am I pulling across the network that is redundant? LeBron's first name twice, his last name twice, his birth date twice, right? His person ID twice. Right? So I want to be a little bit more intentional about this. All right? So what I could do is option 2, load up each person, then separately load up each email, or load each email for each person. Right? That means that down here, after I've closed all my resources, I'm going to open them all up again and make another query for each person in my list, whether or not they have any emails or not. Opening and closing resources like this is extremely expensive. The initial connection to a database is probably the most expensive thing that you'll do other than sending data over the wire. Right? So I want to go with option 3. Right? Load as you go, ... Right? So I've got my person, and I'll go ahead and add them. Right? But within this loop, I'm going to make another statement. String query. Uh-oh, I've already used that name. So query email, right, is equal to select everything from email, where person ID is equal to, and for now I'm just going to show it to I don't even want to show you the bad way of doing it. All right. Well, what is the person ID? It's this thing right here. On the first iteration of this while loop, it'll be Mr. Barr. On the second iteration, it'll be me. On the third iteration, it'll be LeBron. Right? I want to be able to get that into here, right? Somehow, that person ID. I'm going to leave that as a question mark for now because I don't know how to do that. In fact, that's actually how you do it. Right? All right, so let's select everything from email. And again, let's troubleshoot this. Let's bring this over here. And I will select everything from email where person ID is equal to, say, 1. And let's see what that gives us. Oh, hey, there's me. 2. No results. 3, there's LeBron, and he gets 2 emails there. Right? So I need to, I have a good assurance here that this is a correctly valid format here. Right? Except let's go back and, do I really need the email ID and the person ID? Well, if I've already got the person ID in my hand, do I need to be pulling multiple versions of it across the wire? No. All I'm really interested in is this address. Right? Pulling that across the wire, now, yeah, granted, it's only a few bytes. But if you were in a real system where you were pulling over megabytes of data at once, right, then that is a huge difference. I'm only going to select out the address from the email for where that person ID is equal to that person ID. Right? I need to formulate that query again. Right? So prepared statement, PS, except that I've already used PS, right? PS email, right? Okay, is equal to con.prepared statement, query email, right? And then result set, rs email is equal to PS email dot execute query. Right? And then I will have another similar while loop here, iterating over that other result set, rs.email.next. Right? Now remember, if there are no results, then this while loop will never even execute. Right? So I'll go ahead and get the address. String address is equal to rs.next or get string address. Right? And then my person p.add email address. There we go. What did I forget to do as I opened up this prepared statement, as I opened up this result set? What should I have done? Immediately jump down to the bottom and close them. rs.close. All right. ps.close. Yeah, are those the correct ones? Nope. I was thinking these down here. Right? So what are their actual names? psemail.close, rsemail.close. All right, let's run that. There's some improvements here that we can still make, but let's go ahead and run that and see if, oops, no value. Oh yeah, that's right. We never actually prepared this, did we? Right? So question mark. Well, what's the address? Once you've prepared the statement, you can set this. This is called a parameter, right? The question mark is a parameter in the query, which can be set by the prepared statement. Right? How do we do that? PS email dot set, and in this case it's an integer, int. Right? There we go. All right. Now the way that you do this is you use one indexing if you have multiple parameters, right? And then you specify the variable value. So I want to set the first parameter there, and there's only one, right? If there were other parameters like question mark, question mark, question mark, right? Now there are 4. You use one indexing. Don't ask me why, it's stupid. But the first one is going to be 1, second one 2, third, fourth, and fifth, right? You don't use zero indexing like you do arrays. And then you set it equal to these person's ID, person ID. There we go. Right. That I already pulled out from the database up here. Right. There. Set integer. Oh, I get rid of these before I forget. That was just an example. Right. So the parameter, it's a parameter that gets set. We prepare the statement, we set parameters, and then we execute that statement. And now this should actually work, except there's something else. Address, not found. Oh, what did I call it? Address. Oh, I screwed up yet again. Remember, RSPS, you know, you're going to have to name them all, right? And this one, it should be email. RS was referring to this one up here, right? For that reason, let's go back and rename these things, right? The convenient way of doing this is going to be highlighting it, right-click, refactor, rename. So what should I name this instead? PS person? Right. There, it's changed everywhere. RS, let's go ahead and refactor that and rename it RS person. There we go. It's changed everywhere for me automatically now. And now it's really clear. Why are you trying to access the address of the result set for the person? RS email is what it should be. Right? Good naming conventions. There we go. There's my email. Babe Ruth does not have any emails. And there's LeBron James's 2 emails. Okay. Blake Snell, Mr. Barr, Mr. Fu don't have any emails. Wow. All right. That's a lot of code, lot of code, lot of code. Should this be in a main? Probably not. Let's go ahead and create a data loader class. Data loader. Now you probably already have a data loader class, right? A data loader class for what? What is it loading from right now in your projects? CSV. So let's replace that with a database data loader class. Right? Now, if you had a good design in your current project, you should be able to use, again, remember, dependency inversion, right? If you're loading up from a bunch of CSV files and then you have a new class that loads up from the database, right? You should be able to only change maybe 1 or 2 lines of code after you've written this database data loader class, and everything should work exactly the same. If you don't have a good design and you're loading stuff up and you've mixed in all of your code and you've got a big giant God class, you're going to have a rough time. You might want to go back and refactor it so that it's separate. Right? Because what I want here is a public static list of load persons. There we go. From database. Right? And now I'm going to bring, I don't care about person anymore. I'm going to bring all of this stuff over. And instead of printing it out, I'm going to go ahead and return everyone. Everyone's not a great variable name, but whatever. There. Right. Now over here in my main, I don't need all that code. Instead, I can just have database data loader dot load persons. There we go. And list of everyone is equal to that. There. Now, why would I want to do that? Probably because I'm also going to be loading up assets. I'm going to be loading up, you know, a bunch of other stuff, right? If I offload that to another class into another method, I'm going to have a lot easier time. And we've been recommending it over and over again since like week 2. Lists are great, but what's even better than a list? A map. Why would a map be good? Especially now that I've got a database. I could map an integer to a person. What would that integer be? The person's person ID, right? So let me go ahead and change this. Import map. There we go. And let me show you how you could go about doing this. I've got a map of persons. Come on, bring it in. Import. There we go. All right. And it needs to return that value. So not everyone here. Let's see. Where do I add it? There. Instead of adding it, I will put person ID mapping to that person, P. Right? Why are you complaining? Incorrect number, oh, person, sorry, integer 2. There we go. There, that's the correct number of parameters. What are you complaining about down here? Where are you? Put. Oh, dot put, isn't it? Put. Come on, you can do that, can't you? Int per, oh, everyone is still a list. Thank you. Yes, there we go. All right, get rid of that. Make this into a map. There we go. Everyone, and then a new hash map. There we go. Import that, and we should be good. There we go. That's much better, right? Because if you still wanted to print everyone out, you can. Just print out their values. And I get the same result as before. But if I'm looking for a particular person, right? Person LeBron, there we go, is equal to everyone dot get, well, what was their ID? I think it was 3, right? There we go. And let's print out LeBron, just LeBron. System.out.println LeBron. There he is, right? Okay. Why would you not use maps? Once you've seen maps and once you've used them for one thing, you will never ever go back to a plain old list. Sometimes you do want to go back to a plain old list and you want the values. But trust me, you want to start using maps, especially if you're coming from a Python background. In Python, you have lists, of course, but once you've seen a dictionary, do you ever want to use a damn list again? No, you want to use dictionaries everywhere, right? So there are some improvements. One other, question online here. Good question. I can barely read it though. Use a formatted string. Yeah, okay. So I think what the question is referring to is this. So if you've got a very long query, in fact, let me do it up here. All right, string long query, right, is equal to some really, really long query like this. For example, that join query right there, right? Am I going to be able to do that in a plain old string? Well, it's going to look ugly like this, right? Something like that. Right? Here's a better way of doing it in modern Java. In fact, those coming from a Python background will immediately recognize this. 1, 2, 3, 1, 2, 3. That's a string, right? What kind of a string is that, though? Oh, no. Do I not have any Pythoners in here right now? No? Hopefully you did this in Python. What is that? It's a multi-line string. You can put whatever you want in there and it'll treat it as one big giant string. It'll ignore leading white space. So if you want to, you can. I don't want that. Come on. Sorry. Come on. There we go. I'll go ahead and put it right here. Get rid of this blank line right there. And then, there we go. And there. Right? And then align it like that. Right? So you could put a whole big query in here with a multi-line string. Quote, quote, quote. 3 quotes, and then 3 quotes ends it. Right? So yes, you could do something like that to answer the question online there. Unfortunately, it's not like Python where you can format a string, say, and have something like this, person ID. You can't do that in Java. That would be cool, but you can't do that. Nope. So if you're coming from a Python background, yes, you can have multi-line strings like this. All right, we'll pick it up there next time.